but we are going to get Tally's team up here, and we will get this squared away and get this code review going. Raf, what's going on? How are you?
I am doing well. Good to see everyone.
Awesome. Let me see. Who else did you want up here with you today? You wanted Keating and
I see
Ben.
Keating in the audience. Let's invite him up.
There he is. We'll invite him up, and then not seeing Ben, unless I'm
Yeah,
blind.
Ben's not in the chat yet, but I think he's joining soon.
Okay. Well, as soon as he joins, we can invite him up. But so the way this works, we typically slot about 30 minutes, typically about 20 minutes for the code review with the community, and then about 10 minutes for Q&A. If there's no Q&A, then obviously you can kind of just keep doing your thing for about an extra 10 minutes. Other than that, if you are ready, feel free to hop up and do your thing.
All right. I also see Ben just joined, so if you could invite Ben up to the stage. Welcome, Ben. And thanks everyone for being here. We wanted to today give you the walkthrough for the repo called stgov, which is a liquid staking wrapper built on top of another repo, Staker. And the high level idea of stgov is it is a liquid staking token that's compatible with governance tokens. So people can have their liquid staking token, and also it can do all the things that governance tokens do, like delegate their voting power and be active in um, governance. So Ben and Keating have the most context on the code. So I want to hand over the mic to them. Maybe Ben, do you want to start if your mic is ready to go and hooked up?
Hey, yeah, can you guys hear me?
Yes, loud and clear.
Awesome, great. So let's see. Where's the Fergie or anyone else from the Cantina team? What do you suggest here how to go about this? Should I share screen and walk through some code? Like, what do you see as the best way to handle it from your experience?
Yeah, just share your screen and walk us through it as if you were, connected to a projector or whatever at a conference.
Okay, awesome, cool. That's what I figured, but just wanted to sanity check that. Let me see if my screen share wants to cooperate. Um, let's see. Okay. Uh, all right. Hopefully that's popping up for everyone. I'll blow it up a little bit.
Yep, you're all good. We can see it.
Looking okay? Cool. So I have stgov here. I'll also pull up Staker because this is probably going to come up, and there's probably some things that we'll have to reference here. As Raf mentioned, we have this system called Staker, which allows users to stake their governance tokens or any tokens, but it's compatible with governance tokens. That's one of the nice things about it. And when they stake their governance tokens, they can also select a delegate for their deposit, and they are thus able to earn rewards that are distributed by, say, a DAO or any system like that that is distributing rewards out to people who stake, while maintaining, if it is a governance token, their delegation to whoever they're choosing. It could be themselves, it could be another delegate. And Staker is actually built on the system called Unistaker, which is in the process of being adopted by the Uniswap DAO to enable the distribution of fees, reward fees from the DAO to as rewards to participants in governance. And Staker sort of takes the idea of Unistaker and builds on top of it. One key thing that Staker adds that Unistaker didn't have is the concept of an active or inactive delegate, or more broadly speaking, the concept that how much you earn as a staker is tied to how much you deposit, or sorry, what your delegate is doing with their participation in governance. So in your deposit, which you see the struct here that tracks the deposit, you choose a delegate, or as we usually call it, a delegatee, to refer to the noun form of delegate. The delegatee is, a governance delegate, and then based on their activity, your earning power will scale up or down, and that earning power determines how much you earn. So it's not just how much you stake, which is represented in your balance. It's your earning power, which is defined by what your delegate does. And in particular, there's in the staker system, there's something called an earning power calculator. That is a module. You can see we import it up here. And then let's see, I'll just look for the variable where we set it. Here, there's an earning power calculator variable or a storage var that defines an external contract. And if this were a DAO, the DAO would be able to update this contract. But what the earning power calculator does is returns what a given staker's earning power is based on their balance and who they're delegating to. So all of this is within the staking system, the core staker system. And to understand STGov, you need to at least have these high-level concepts. So I'll let you guys dig into the staker system a bit deeper. There was a previous contest on that. You can see the findings there. The audits are published in this repo if you want to review that. There's also documentation available. But the core idea is that when you deposit into staker, your position isn't liquid. It's just a single position. You earn rewards and you accrue rewards based on your earning power, which is defined by the earning power calculator, and what your delegate is doing, right? The earning power calculator can figure out how to determine your earning power in a number of ways. It can observe things on chain. It could use an oracle. There's different approaches that a DAO could choose. But in general, there's this modular component of the system that provides that information. So with STGov, what we're looking to do is build on top of Staker to provide a liquid option for this type of staking, right? So in Staker, you deposit, you have a position, you accrue rewards. You can go in and claim those rewards anytime you want, but they don't auto compound. And you can't transfer your position, but you can withdraw from the position at any time, right? And again, your earning power might change in the system based on what your delegate is or isn't doing in their participation of governance. So with SDGov, we want the position to be liquid. We want you to be able to stake and receive a receipt token that represents your liquid token in the system. We want you to be able to transfer that token around just like you would any other ERC20 token. We also want you to be able to maintain your delegation in the same way that we did with Staker. So you can select who you're delegating to, and that delegate should receive your voting weight for the governance token, the ERC20 vote style governance token that you've deposited. And then in addition to that, you should be able to auto compound the rewards. So unlike Staker, where you have to claim the rewards on your own, we want the LST to be an auto compounding system. So just by holding the token, you should see your rewards accrue over time, and then you can, at a later date, convert from the LST back to the underlying token, and your additional balance is represented. So that's the high-level idea of STGov, and to accomplish that, we've built the system where we have this core Gov LST contract. And the Gov LST contract is where the meat of all the accounting and everything that's related to this system is really taking place. So what the Gov LST contract does is manages a bunch of deposits in Staker on behalf of the depositors, the holders of the LST token. So when you deposit in, when you stake into Gov LST, the contract creates and manages a underlying deposit. When you move LST tokens around, when you send them from one address to another, the the STGov contract manages moving those tokens between deposits that it manages, such that your governance power, your voting weight, is also moved between the delegate that you've chosen and the one that is should receive it when it changes. So that's, again, the high level idea. There's a lot of details to get into, which I'll start diving into next. But at a super high level, we have this idea of staker, non-liquid position, delegates your tokens, allows you to manage deposits. STGov is a liquid token built on top of it, manages a bunch of staker deposits on behalf of all the LST token holders, and does the internal accounting to make sure that all of that works. So I'll maybe pause for a second if there are any super high level questions. If not, I'll continue on into some of the details.
I'd say you can keep chugging along for now.
Cool. And, Keating, Raf, if either of you guys have any thing that you want to raise, feel free to do so at any point and interrupt me. So, yeah, so there's a lot of detail here. You guys are going to obviously have to dive into that and understand it. But let's take a quick look to start at maybe the stake method. This is a good place to maybe begin. So when a user stakes their when they call stake, what they're doing is they're depositing their let's call it their gov token, their governance token, and they're receiving back their LST token instead. So there's a lot of optimizations done here for gas savings. So we're loading things into memory and then committing them back to storage at the end. That kind of stuff is happening. But the core thing to recognize here is we do a few things. One is we update the balance of the user. So obviously, it makes sense that we would want to do that. We account for the user having deposited this. We also issue shares. So the user, this system is a rebasing system. So you get shares that represent your static fixed claim on the system, and then as rewards are distributed into the system, your shares, as the balance of the system increases, your shares are worth more of the underlying token, and your balance of increases automatically because that's calculated dynamically, as you can see if you look at that. So we issue you shares. We account for this in the total supply and total shares of the system. And then here's something that's important to recognize, we stake in the underlying staker system. So we actually we add to a deposit in the underlying staker so that the tokens that you've deposited can now start earning on your behalf. And one thing that's important here is that we stake specifically into a given deposit ID. So the LST system manages a bunch of deposits on behalf of stakers, and it determines which deposit those tokens should go into based on which delegatee the user wants their voting weight to go to. So who the holder of the LST token is choosing to delegate to. So if we were to look at this calc deposit ID function, we would see basically what it's doing is a lookup. Maybe we can jump to that. But the more important thing is that it is, at the end of the day, determining based on, it might be tough to find this. Let's see. There's a lot of calls of this. If I can't find it real quickly, I'll move on, but it's not super important. Here, let's see. Function, calc deposit ID. Here it is. So it's doing something really simpler, which is basically just looking up the deposit ID that's stored in the state and using that, or it's returning this default deposit ID if the user hasn't sent one. So the important thing here is if we look at update deposit, the user gets to define a deposit ID in the staker system. So staker has a unique deposit identifier for each deposit. The LST manages a bunch of deposits. The user gets to pick which deposit they want, and which deposit they pick basically determines or directly determines which delegatee or delegate that they're choosing to delegate to. So the logic here is, a bit complicated. We don't have to go through all of that. But the important thing is that when the user selects a deposit ID, we move their tokens into the underlying deposit that delegates, that chooses that delegatee, that delegates to that delegate, right? And so when tokens are moved around in the system, we actually have to move the tokens between different deposits to ensure that the tokens are always going toward the correct delegatee. So we unstake and stake into different deposits, all of which are owned by the LST and all of which are associated with a specific delegatee. So to repeat that again, the LST manages a bunch of deposits. Each deposit is associated with a specific delegate, and users select a deposit ID as a way of choosing which delegate they're going to delegate to. So when tokens are moved, we move the underlying tokens between different deposits, doing all the accounting as needed to ensure that the holder's voting weight is moved to the appropriate delegate. So again, maybe I'll pause for a real brief second in case there's anything that needs to be raised, but we'll move on from here to understand some of the other points of important details that are going to come up in this audit for sure.
Yeah, I'd say we can keep chugging along. No questions yet, guys. If you do have questions, feel free to just drop them in the chat for this stage, and then we'll get to them as we continue chugging along. We have about maybe another 15 minutes left, so feel free to keep doing your thing, man.
Cool, sounds good. So I'll go a little deeper on this concept of the default deposit now. So let's say that a user stakes or a user is sent tokens, but they haven't explicitly selected a deposit where their voting weight should go. In other words, they haven't picked a delegate that they want to delegate to. Where should the user's voting weight go to in that case? So in those cases, we have this concept of the default deposit ID. So this is an address, or sorry, a deposit that is that delegates to a specific delegatee, and it is controlled by a trusted party, could be the DAO, for example, in the system that decides who that default delegatee is, and the voting weight of a given holder of the LST goes to this default deposit if the if the user hasn't specified who that should go to. Another way in which tokens go to the default deposit is when rewards are distributed. So we should talk briefly about that because that's an important point as well. Let's see, is it distribute reward? Yeah, claim and distribute reward. So let's find that. So this is a public function that anybody can call that basically allows you to claim underlying rewards from all the deposits. So each deposit that the LST manages is accruing rewards based on its depositors, based on how much is staked by the various holders. And a neutral third party can come in and claim all the rewards for those deposits as long as they provide a specific amount in return. So they provide the payout amount into the contract and they collect all the rewards. And so the idea is that searchers or MEV bots will basically look for the opportunity when this becomes profitable. And once the rewards have accrued enough such that they can provide the payout and get more rewards than they're getting back, then they'll call this, and there'll be a race amongst searchers to do this first, and therefore to do it in the most efficient way possible once it becomes profitable as well. So there might be a small amount of value leaked out to the searchers that call this, but overall we expect it to be competitive. If it's not competitive, the DAO could always run a service themselves that does this, subsidize it to run. But given that it would be a profitable opportunity, we expect that searchers for any sizable DAO would call this. And what happens is when this happens, we can issue fee shares. That's sort of a detail here that there is a fee that can be issued, but we to the owner of the LST contract. But then basically what we do is we take those rewards and we distribute them out evenly to all LST holders because, again, this is a rebasing contract. Holders have underlying shares. So the distribution of this reward increases the balance of the underlying tokens that are held, and therefore each share becomes more valuable. So This is how rewards are distributed. That's the mechanism there. Obviously, a lot of underlying detail, but that's the high level summary. And I'm going to keep flying past this because there's some more important things to get into. But the last thing that I'll note is when we do that, the tokens that are distributed as rewards also go to the default deposit, because we can't iterate through every single deposit and cut up the rewards and distribute them to each deposit according to the right proportion. So we give them all to the default deposit, and we do the accounting such that the user has a share of their tokens to their delegate and a share to the default deposit, and they can at any point that they like, choose to reclaim those tokens or move those tokens from the default deposit to their chosen delegatee. But until they do, they also sit on the default deposit. So that's the reward distribution mechanism at a super high level. And with the remaining time, what I want to talk about is related to this idea of overrides. So I mentioned when I kind of gave the whirlwind tour of Staker that Staker has this idea of earning power and an earning power calculator, and that each deposit earns a certain at a certain rate. It has a certain earning power based on the behavior of its delegate. And this calculator can be determined by the DAO, but it can use something like an oracle or observing on-chain data to determine what each delegate's earning power should be, and therefore what each deposit's earning power should be based on the delegate that they've chosen. So you might stake 100 tokens, but if your delegate is inactive, you might have 0 earning power, or maybe you might have only 50 earning power. Or maybe if the DAO has chosen to give you some kind of bonus, you might have 120 earning power, even though you've only staked 100 tokens, right? And your rewards are distributed relative to your earning power, not to the amount you staked directly. So because different deposits in the system might earn more based on their delegates, this creates a problem for the LST. Because let's say I choose a delegate who's active. I stake 100 tokens in the LST. I choose an active delegate. My earning power is equal to 100. But let's say, Raf chooses a delegate who is not active, and his earning power is actually 0. So he's not earning anything. Well, the collective earning power of all the deposits that the LST owns is now going to be only half of our total balance. And I would be basically subsidizing Raf's holding if we allowed him to pick an inactive delegate, and he would be making the yield of the LST for me as another holder less than what it would be to simply be in the staker. So the way that we solve this problem is with the concept of overriding. So if a deposit is not earning at a certain threshold of earning power, then that deposit can be overridden. And what it means to enact the override is to move the deposit's delegatee to the default deposit. And so the assumption is that the owner of the LST, which would probably be the DAO, is always going to make sure that whoever the default delegatee is remains active. And if they become inactive, or they're not earning at full earning power, they'll move that delegatee to they'll move the default to some other delegatee. So the default delegatee is assumed to always be active. And if the delegate you've chosen, right, if you've picked the delegatee that's not active, that's not earning at the threshold, then the enact override method allows someone to call this method, move that deposit over to the default delegate so that it can start earning at the full earning power again. And we calculate like a min qualifying threshold, right? And then if we're above that threshold, then we don't allow you to override. But if we're not, now we can have the delegate, we can alter the delegatee of the underlying staker deposit to use the default delegatee. And we can remember that this deposit has been overridden. And we can issue a tip to the person who has called this enact override. So again, we're imagining sort of a robust searcher market where people will track the states of different deposits. And if they are no longer qualifying for the max earning power, they can call enact and earn a small fee for keeping the system up to date. So we enact the override if the deposit becomes, if your delegatee becomes inactive or is not earning at the full earning power, the minimum earning power. But we can also revoke the override if your delegatee now starts earning at the appropriate earning power. So let's say, Raf chooses a bad delegate, he's not earning a lot, it gets overridden. So now he's moved to the default delegate, but now his delegate becomes active in the system again, he's earning above the threshold. And so someone can now revoke the override to move Raf's deposit back to the delegatee of his choice, so that the voting weight isn't all accruing and sitting over time with the default delegatee. So that's what the revoke override method does. And then there's one more override method, which is called the migrate override. This is a little bit nuanced, but because the controller of the LST, the admin of the LST, which again might be the DAO or some entity like that, has the ability to change the default delegatee, there could be a deposit where it was overridden to the default. The default has since changed, so we need to migrate this overridden deposit to the new default. So to play on our example, Raf delegates to someone, that person is inactive, the deposit gets overridden, it's now with the default, but now the default delegatee changes because the owner of the LST decides to do that. Now we want Raf's deposit to be migrated to the new default, and that's what this method does. So that's not one we expect to happen frequently, but it is a possibility, and so we also provide a method here for that. So this is really a whirlwind tour. There's a lot of detail, obviously, in all of these contracts. There's probably one more really important thing to mention. So I do want to do that, even though I know we're at time here, I believe. But before I mention that last thing, are there any questions that need to be addressed for what I just went through?
I'm not seeing anything new, so we're good to keep going.
Cool. So the last thing I want to mention, and again, this is going to be a whirlwind, but I'll try to at least give you guys a hint of where things that are important to look at are. So I've been talking about this Gov LST contract, which, as I mentioned, is a dynamic rebasing LST. So your balance goes up. It's like Lido, right? You get issued a share. If more ETH is added, then the amount you own goes up and your balance automatically increases. So it's a rebasing style LST. We know that some folks will want a fixed LST. Those could be integrators. It could just be the DAO would prefer the fixed model, whatever it is. And so we have basically kind of what's the best way to describe it? Like a sister contract to the LST contract, which is the fixed Gov LST contract, which basically exposes the shares of the LST. So the shares which are fixed in the LST become your balance in the fixed Gov LST. And so in this case, your balance in the fixed Gov LST doesn't translate one-to-one with the balance of the underlying. Instead, there's a conversion rate, and that conversion rate changes over time. A lot of times, like for example with Lido, this is accomplished with a simple wrapper contract. But because we want to allow users to maintain their delegates and therefore their delegation, and therefore we have to segregate funds differently internally in the LST based on who they're delegating to in these different staker deposits, a simple wrapper wouldn't work as well for this LST because every token in the wrapper would simply be delegated to the default delegatee unless the wrapper selected a delegatee. But then again, still only one delegate. So we want users to be able to hold a fixed representation of the LST without losing the ability to select their own custom delegate. And so the way that we've done it is we've created this sister contract, the fixed LST, and the fixed Gov LST actually has special permissions to call special methods inside the standard rebasing LST, which allow it to convert to a fixed balance and do these different things. So the important thing here is that these contracts are paired and trusted, and the way that that's accomplished is the Gov LST in its constructor actually deploys its paired sister fixed LST contract. So it deploys the fixed LST contract, it remembers where that contract is located, and then there's a bunch of fixed LST helpers that are permissioned methods that only the fixed LST contract can call, that allow it to do internal accounting in the rebasing LST, converting basically the fixed LST balances to the rebasing LST balances. So this allows these two ERC20 tokens to coexist next to each other and just have different, with the same accrual, the same mechanisms, the same mechanics, but just expose basically different values for the balance. In one case, the balance that's exposed is the rebasing balance, the live balance that is one-to-one with the underlying value. And in the other LST, your balance is fixed. It doesn't change. What changes is how much of the underlying governance token you can exchange that token for to get your to get back your underlying token. So these coexist, and they both allow you to pick your delegate and maintain your delegation. But they do this by having these permissioned helper methods, which only the fixed LST contract can call. And we call those out clearly in the contracts. It should be evident when you get in there, but I want to call it out as something important to look at. So that was definitely a whirlwind tour. Obviously, there's a lot of details under here that I think should become apparent as you dive into the contract. They're all well documented. We have some other external documentation that I think Raf has already linked to or pointed towards. But that is sort of the quick tour. And if Keating and Raf feel like I missed anything, would be happy for them to speak up. If there are any questions, I'd be happy to cover those as well.
Sweet. Well, I definitely appreciated Bendy, and I'm sure everybody in here does as well. Raf, Keating, any final words before we wrap this up? Anything from your side?
Nothing from me, no.
Okay, sweet.
Would love to hear any questions from the audience now, or also you can follow up in the Tally Discord channel on this Cantina. We'll be monitoring that channel.
Okay, sweet. So
Yep.
there you go. They'll be here. They'll be in the Tally channel. Just to remind everybody, this will be uploaded to YouTube. So if you came in a little bit late, it'll be on our YouTube in about an hour, give or take. Don't forget, $15,000 competition plus $10,000 private pot for the fellowship, March 10th through March 17th. It is active, so go check out the Tally channel for all the links. Other than that, appreciate you guys coming today and giving the community a little look into what they can expect as they dive into your contracts.
Awesome. Cool.
Right.
Yeah,
Thanks,
we'll
guys.
be as responsive as possible in that shared channel. So as you get into it, if you have questions, don't hesitate to hit us up.
Great. Well, we appreciate it, guys, and we'll see you later after the competition's all said and done. Bye for now.